Potentiometer is a device used to measure EMF of a cell. Potentiometer generally consists of a wooden board on which a uniform Manganian wire of length 4 meters is fixed in parallel rows between two binding screws A and B by the side of a meter scale. A jockey is provided to make a contact at any point of the wire. The potential difference epsilon or E between any 2 points of the wire is directly proportional to the length of the wire between two ends. Epsilon is directly proportional to L. Epsilon is equal to phi into L. What is phi called here? Phi is the potential drop per unit length of the wire. So let us see what is the principle of a potentiometer. The potential difference E between any 2 points of the wire is directly proportional to the length of the wire. Let epsilon be the potential difference and L is the length of the wire. Epsilon is proportional to L. Epsilon is equal to phi into L. Now let us see what is meant by phi. Phi is the potential drop per unit length of the wire. Now we have to compare the potential differences of two cells whose potential differences are epsilon 1 and epsilon 2. To measure the potential difference or ratio of the potential difference of two cells or EMFs of two cells, here in the primary circuit a plug key K1 is closed. In the first position the points 1 and 3 are connected. Then epsilon 1 will be connected to the electromotive force of the first cell. Epsilon 1 will be connected to the galvanometer. At this point we have to measure the balancing length L1. According to the principle of the potentiometer, we have to find out the null deflection of the galvanometer. Electromotive force epsilon 1 is equal to phi into L1. In the second position 2 and 3 points are connected. Then again we have to find out the balancing length L2. Therefore, according to the principle of potentiometer, electromotive force epsilon 2 is equal to phi into L2. According to the first equation, epsilon 1 is equal to phi L1, epsilon 2 is equal to phi L2. Comparing 1 and 2 or dividing 1 and by the second equation 2, epsilon 1 by epsilon 2 is equal to L1 by L2. So this is the ratio of EMFs of two cells is equal to ratio of their balancing lengths L1 and L2. Epsilon 1 by epsilon 2 is equal to L1 by L2. By the way, now we are going to see how potentiometer is used to find the internal resistance of a battery. The construction principle of potentiometer that we have already discussed to compare the EMFs of two cells is the same thing as the determination of internal resistance of a battery. But the difference in the circuit can be noticed here. In the primary circuit, as usual, batteries, rheostat and K1 are connected in series. It makes the difference in the sense that in the secondary circuit, the internal resistance of a battery whose internal resistance will be measured and resistance box RB are to be connected in parallel. The other end of the resistance box is connected to the key K1, key K2, and these two are connected to the galvanometer followed by a jockey J. First step, the K1 is closed, keeping K2 open. The position of the balancing length L1 is noted. Therefore, according to the principle of potentiometer, EMF of the cell epsilon is equal to phi L1. In the second step, key K2 is closed. Then again, the jack is adjusted to find the null deflection of the galvanometer. Then the balancing length L2 is noted. But the terminal voltage V is equal to phi L2. We have already seen the first equation, epsilon is equal to phi L1 and V is equal to phi L2. Dividing 1 by 2, epsilon by V is equal to L1 by L2. The electromotive force epsilon is equal to I into capital R plus small r, where big R is the resistance of the circuit which is measured from resistance box, and small r is the internal resistance of a battery. According to Ohm's law, we know that V is equal to IR. Dividing these two equations 3 and 4, epsilon by V is equal to R plus R by R. Therefore, R plus R by R is equal to L1 by L2. That implies 1 plus R by R is equal to L1 by L2. When you bring this R by R to right side, it will turn out to be minus. Small r is equal to big R into L1 by L2 minus 1. Using this formula, we can find out the internal resistance of the battery. Therefore, the internal resistance of a battery small r is equal to big R into L1 by L2 minus 1, where small r is the internal resistance of a battery, big R is the resistance measured from resistance box R, L1 and L2 are their respective balancing lengths. Thanks for watching. Please do like, share and subscribe Cinema Search Agency to get the continuous updates.